The Leetcode challenge today. We have minimum number of operations to move all balls to each box. In this question, it says you have n boxes, which is represented by this string here. You're given a binary string, boxes of length n, where boxes of i's is 0 if the ith box is empty, and it's 1 if it contains one ball, right? And it says in one operation, you can move one ball from a box to an adjacent box. So we could move this ball either to the right or to the left. For example, not this one, either to the 0 or to the 1. And it says box I is adjacent to box J if they are, the difference between them indexes is 1. And then it says note that after doing so, there may be more than one ball in some boxes, right? Return an array of size n where answer of I is minimum number of operations need to move all balls to the ith box. So basically, once an array of answers where for every index, what's the minimum number of operations to move all the balls in boxes to this index, right? Yeah, and we should start from the initial state of boxes. So the simulation is run on boxes every single time as it is new, right? Okay, small tip for this. This has a high pass rate because apparently the constraints is just 2000. So brute forcing this actually works, and I've tried it right here where you just double loop on boxes, and if they're the same index, skip it. And if boxes of I equal 1, then we just need to calculate the difference between the indexes, between where let's say we start off an I where I is like the first index, right? And then J is like the second index, right? Like right here, it's iterating right here, right now. Basically, if boxes of J is 1, which is like, this is 1, we add to I, which is the first index in the iteration, we add the difference between the indexes, the absolute value between the differences. So basically, we add 1 minus 0, which is going to be 1, right? And then we keep doing that for every single index we find in the rest of the array for the first index. And then when we finish, we go to the second index and we do the same thing over and over and over and over. So time complexity wise, it's O of n squared, but it actually passes. But it's actually really slow. It took almost 4 seconds, 3.7 seconds. How can we make this better? It's using prefix sum. Okay, so the idea here is for every index, right? For every index, what I do is essentially, let's work with this example, right? Let's say for this index, right? Well, we need to add every ball to this index, right? So there's 2 1s at the end. So what do we actually do, right? Let's say for this one, we're gonna subtract or take the absolute value of the difference between that index and the index I want the ball to be in, right? So this is 0, 1, 2, 3, 4. So it's 4 and 2, right? So there's 2 operations to move this to this, right? So 2 operations means it's gonna be 0, 1. It's gonna be 2, 3, 4. Yeah, 2 minus 4. So it's gonna be, this is the 2, right? And this is the 4, right? And then for the last index, we do the same thing, but a different index. So it's gonna be basically 2 minus 4 for the first one in the highlighted area, and 2 minus 5 in the second one. So it's gonna be 2 minus 4 plus 2 minus 5, which is gonna give me 4 minus 9, which is gonna be 5, right? This is how it is. So you just basically stack the you stack the differences of indexes. Basically, that's the simplest thing, where you, for every one you find, so let's say we want the boxes in this index. For every one to the right of this one and to the left, we count the number of ones, right? And we multiply that by the index of the current box I want. And we add that to all the differences of indexes we found, right? Basically, that's how it is. So the equation is, right? The equation is, let's say we have this one, right? So it's going to be 0, 1, 2, 3, 4, 5, right? So it's going to be the first index is going to be, what's the first calculation? It's going to be 2 minus 4, we finished this one, plus 2 minus 5, right? And then if it goes on, plus 2 minus 6, plus whatever. So if we see the 2's, which is this index, gets repeated as many ones as there are other than the current one. They get repeated that much once, right? And they're all subtracted from the indexes of the other ones. So basically, the equation can simply be, it could be as follows. So it could be current index, right, multiplied by how many ones I've seen other than this one, right? Ones count, let's call it ones count, right? Subtract that from all of the indexes, like all of the ones indexes, and that gives you the answer required for that specific index. So we need to apply this equation. We apply this equation using prefix sum. So basically what I did, I had two loops, right? I looped from right to left to calculate the prefix sum from right to left, so I can get every one on the right of that current index, and I calculated it from left to right to get every one on the left of the current index. So what I did basically was I had these two variables. This is a variable that counts the number of ones I've seen, and this is a variable that counts, that increments the indexes, basically, so we can satisfy the equation I just wrote. So we go right to left, and we have the prefix array, which is going to be the answer at the end. But I fill it at first, I fill it with that equation, which is the current index multiplied by how many ones I've seen, minus the indexes count, basically. The count of the sum, not the count, the sum of the indexes I've seen that have ones. If boxes of I is equal 1, I increment this variable, and I increment this variable with the index, right? And then we have the right side. We do the same thing from left to right. The same exact thing, but instead of here having the equal, we have plus equal, right? And then after doing that, basically we are guaranteed the answer in O of n time. It's actually 2n, but we could simplify it to n instead of having this O of n squared. So yeah, that's been it. If you have any questions, make sure to comment. Don't forget to like and subscribe. Thank you for watching, and see you soon.